Hi class, I found this image of composition, so I just had to share it with you before I jump into the rest of the notes. I thought it was a good visual representation of that composition with input, output, and how order matters there. Where we left off in class, we were getting ready to start about symmetry. So in this course, we're going to be discussing symmetry with respect to the x-axis, the y-axis, as well as to the origin. Okay. So I have two examples below, and we'll work through them both. Realize that when we discuss symmetry to the x-axis, we are referring to whether or not the image is a mirror image over that x-axis from top to bottom. So if we were to fold that like a piece of paper in half, would the two sides line up? When we talk about it being symmetric to the y-axis, it would be folding that paper in half along the y-axis, so the left and right sides would need to match up. And if we talk about symmetry to the origin, what we're saying is that if we took this whole thing and we rotated it 180 degrees, would it still look the same? Okay, so if we take a peek at that very first image, it is actually symmetric to the x-axis. If we look from left to right, it's symmetric to the, whoops, I said that backwards. If we look top to bottom, it's symmetric to that x-axis. It is also symmetric to the y-axis. If we look left to right, it's symmetric to the y-axis. And if I rotated this whole ellipse 180 degrees, I would get the exact same shape I'm starting with. So this is also symmetric to the origin. So that one actually ended up being symmetric to all three. Okay. Now, if I look at this next image, when I look at the x-axis, this has symmetry. When I look at the y-axis, there's nothing even on the other side of the y-axis, so there's no way we could have symmetry to the y-axis. There's no way we could have symmetry to the origin, and that's it. So this one only has symmetry to the x-axis. Okay. Now, the last part of this module talks about parent functions. And parent functions are something that you are really going to make sure that you know. Things like, what's a quadratic equation look like? What's the equation of it? What's a cubic function look like? What's the equation? You're going to want to know the domain and range for those. But you're going to find a really nice list of all your parent functions in your class notes H. Okay? I would encourage you to maybe even make flashcards and quiz yourself, because it's going to be super important that you have that foundation and know all of your parent functions. There's 8 of them. Next week's quiz, you are going to be asked to recall the information about 2 of those parent functions. So I'm going to pick a random 2 out of that 8, and you need to make sure you know it for next week's quiz. And that will be by memory, not with notes. Okay. And when we look at that quiz, I'm going to ask you the name of the function, the equation of the function. I'm going to ask you for the domain, the range, and the symmetry of that function. And you're going to see all that information in class notes H. So make sure that you're prepared for that. Now, once you know your parent functions, it's real easy to move them around. Left, right, up, down, maybe a reflection over an axis. And I've got a little acronym here, IHOP and OVEX, that will help you remember what some of those transformations are. When we talk about IHOP, the I stands for inside. The H stands for horizontal, so we're talking about moving left and right. And the O and the P are actually grouped together, and they stand for opposite. Okay. In OVEX, the O stands for outside. the V stands for vertical, so now we're talking up and down. And the E and the X are grouped together, and that stands for expected. Okay. Now, this little acronym only addresses left, right, and up and down, but it's a good little way to remember those four at least. You'll, again, find in your notes a nice little chart that has all of these listed out for you. Okay. So, if I look at the graph below, and it tells me that it's a transformation of g of x equals x squared. So my parent function is x squared. And hopefully we know that that is a parabola that's centered at the origin. Okay. We want to now use what we know about that parent function to write an equation for the function that's graphed below. Okay. So think about the parent function x squared would look something like this, and its vertex is at 0, 0. We are moving this whole parabola left 2 and up 2. So we need to think about how that is going to look in our equation. So my original parent function is g of x equals x squared. And so I'm going to start with x squared. Now, if I think about moving x squared to the left 2, this is a horizontal shift. Left and right is horizontal. So if I think back to my IHOP, it's horizontal, so I know that it needs to be inside the parentheses, and that it's the opposite of what I would expect. So my gut kind of tells me, oh, if I'm moving it left, I would subtract. But in IHOP, the horizontal moves are the opposite of what your gut would kind of tell you. So we're actually going to move to the left, so we're going to subtract. So we're going to have x, or because we're moving to the left, I misspoke there. Because we're moving to the left, it's the opposite of what you would think we need to add. So it's going to be x plus 2 in parentheses and then squared. Now we need to move up. Up is a vertical transformation. And so in my O of x, if it's vertical, the number is going to be on the outside and it's going to be just as I would think. So up, my gut tells me it's going to be plus, so it's going to be as expected. So we're going to have plus 2 on the outside. So this would be the equation of my graph over here to the left. Okay. Let's try one more. This time, we're going to look at g of x equals the square root of x, but we want it to be reflected over the x-axis and shifted to the right 6. Okay. So, we haven't talked about reflecting over the x-axis yet, but the example that always sticks in my mind when I talk about reflection over the x-axis, most of this has been drilled into our brains that y equals x squared is a parabola that opens up. Y equals negative x squared is a parabola that opens down. Notice that that negative was put in the front. That's what's going to flip this function over the x-axis. So that's going to work the same regardless of whether our parent function is x squared or whether it's the square root of x. So to first reflect that over the x-axis, we're going to have negative square root of x. But now we also need to shift it right 6 units. So if we're shifting it right 6 units, that means that we are moving horizontally. So it's going to be inside, and it's also going to be the opposite of what we would expect. Now, a lot of times when we think of inside, we think about inside parentheses, which is often the case. But in this case, our grouping symbol is actually that square root symbol. So our inside is going to mean inside that square root. So we're going to have negative square root of x. And now because we're moving right, it's a horizontal move. It's the opposite of what we would expect. So it's going to be minus 6. And that is my transformation. Okay. So make sure that you are looking at those parent functions. As always, if you have questions, come visit me. Otherwise, have a great week. Bye.